Everyone, today we are looking at Leetcode number 340, longest substring with at most k distinct characters. This is a very frequently asked question, so it's definitely good to know how to do this. You can see in the last 6 months it's been asked at Facebook, Amazon, Uber, Microsoft, Google, Snapchat. This is definitely one that you'll see out in the wild, so I highly recommend understanding the patterns on how to solve these type of problems. Okay, so there's two approaches to solving this. One is we can use a brute force approach, and the other is we can use a sliding window pattern. And we can kind of go over the two different ways of approaching that, and then we'll go through the more efficient solution. Okay, so let's take a look at this. Given a string s and an integer k, return the length of the longest substring of s that contains at most k distinct characters. So here we have a string s, which is ECEBA. K is 2, so we need the longest substring that's going to have at most 2 distinct characters. And we can see here the longest substring is going to be 3. It's going to be ECE because we have 2 distinct characters. We have E and C. Here we go. We got at example 2, the longest substring with 1 character, and that's going to be AA. The output's going to be 2 because the longest substring will be that input string. Okay, so let's think about this brute force. What would be the brute force way to approach this? Let's go in the conceptual. We can see we have ECEBA, so S is going to equal ECEBA. S equals ECEBA. And then k is equal to 2. Okay, so we got to get the longest substring with 2 characters that matches that, and then return that that substring, the length of that substring. Okay, so one approach would be, we know we have to have at least 2 characters, so we can go ahead and just get all the substrings. Right? We could just do E, EC, ECE, ECEB, and ECEBA. Okay? And then we can go ahead and get the substrings from C. So C, CE, CEB, CEBA. And then we can start from E and move forward. So we can do E, EB, EBA, and then from B, which is going to be B, BA, and A, right? So that's one approach. We can go and get all the substrings, and then we can go ahead and hash each one of those substrings and see, does it have at least 2 characters? Okay, so this one would work, this one would work, this one would work, this would not work, this would not work, this one works, this one works, this would not work, this would not work, this one works, this one works. No here, this is working, that works, and that works. So now we have all of our substrings that match this condition, which is that there has to be at least 2 distinct characters. And then we iterate through it again and we find the longest substring. We could even just sort it and then just return the longest one at the end, right? So this works, and this is an intuitive way to approach this problem. And if you're in an interview, this is probably what a lot of people will initially come up with. And let's take a look at the time and space complexity of using this approach. Well, anytime we have to get it, if we have a string and we have to get all the substrings, that's going to be quadratic time and space, right? So getting the substrings is going to be O of n squared time, and then we're going to have all the substrings, which is going to be O of n squared space. Okay? And then for each one of those substrings, we have to perform a linear operation. All right, so this O of n squared is actually going to be O of n cubed. Okay, after we have to perform that linear operation on each one of those substrings. And then we're going to have to create space for each one of those substrings. Okay, so that'll just be another n squared operation. So our space will just be O of n squared plus O of n squared. So the approximation will still just be O of n squared space, right? O of n cubed and O of n squared time and space respectively. So it works. It's just not very good. And so how can we make this better? Well, we can apply a very simple pattern that's very common that a lot of problems that are dealing with substrings or contiguous elements employ, and that is the sliding window pattern. Highly recommend being very familiar with this pattern because you can solve many problems just by understanding this one core pattern. Okay, so let's approach this with the sliding window. Let's go ahead and clear our table here. I'll delete that. Okay, and then what was our input string? It was ECEBA. So S is going to be ECEBA, and then K is going to equal to. Okay. So sliding window, right? And I'm going to just go ahead and label the indices here. This will be 0, 1, 2, 3, and 4. So when we're dealing with a sliding window, what's the first thing we want to do? Well, we want to set our variables. Okay, we're going to need a start variable, a window start. We're going to need a window end variable. We're going to need a so far variable, something that is keeping track of the values inside of the window. Okay, and then we need a global variable, which can be max or min, which is what we want to return. Okay, that way we're not storing all the subsequent variables inside of that window. We can just update it if we're just looking for a max or a min. Okay, so let's go ahead and do that. We're going to have a start variable, an end variable. I'll put so far over here, so far variable. I'll put max over here. We're going to have a max variable because we want the longest substring. Okay, and then I'll just set start and end right over here, so we can kind of keep track of what's going on during each iteration. Okay, so let's think about how we want to keep track of everything inside the window. We have a so far variable. What data structure do we want to apply to that so far variable? Well, we're counting frequency. Right? We want to count the longest substring with at least k characters. So we can use an object, right? We can use some sort of hash table. But better yet, because we have to check the length, a hash table, we can't check the length. We'd have to do a linear operation every time we want to check the size of that hash table, how many keys that are in there. That would be a linear time operation. So instead, what if we use a map data structure? Works very similar to an object, except with this we can get the size of that, how many keys that are in that map. We can get that in constant time. So let's go ahead and use a map. We'll use a map data structure. Okay, and what we want to do is as we increment the end variable, it's going to increment from 0, 1, 2, 3, 4. That window is going to expand. We want to go ahead and update that map. So let's go ahead and start this. So here we have our start, which is going to be E. Our end, which is also going to be E. Our max here so far is the size of our so far. Okay, so the initial value for max, we can set it to 0. But now because we have added E, a frequency of 1 on our so far, we can go ahead and update that max because we're going to compare what is originally in the max to what is the current max. The current max is larger, so we're going to just update that. That way we're not storing all those values anywhere. And we save space. Okay, so now what we're going to do is we're going to go ahead and increment. We're going to check, does our so far have less than or equal to two characters in it? It does. There's only one character, that's E. So we're going to go ahead and increment this E here, our end variable. And now we have EC. So our start is still at E. We're not doing anything with that. Our end variable is now pointing to C. We're going to update this C here to a 1. And now we have two characters in this so far, so we compare it to our max of 1. Now we have 2, so we can go ahead and update this max to 2. Okay, let's keep moving. We now increment our end variable to the next index. And now we can see that we have 1E, 1C, but now we landed on an E, so we're going to just go ahead and increment our end variable there. Okay, and now we want to get our max. And I forgot to mention, the way we want to calculate max is that we just want to subtract, because we're calculating the max string, right? What is the maximum substring? So what we want to do is we want to subtract this E, this end, from this start. And then we want to add 1, because here we're representing it as length. So after each iteration, to calculate max, we're just going to go ahead and do end minus start plus 1. That gives us our current max, and we're going to compare that to whatever's already in the max. Okay, so we can see here that our end is going to be 2. It's going to be minus start, which is 0, so that's going to be 2. And then we're going to add 1, so we can actually update this to 3. Okay, this is going to be E. This is still going to be E. Okay, let's keep moving. So now we're going to move this E over here to B. We add this B here, and we have a 1. Now we have a problem, because our size here is now greater than 2. Okay, we're going to check on each iteration, what is the size? This is greater than 2, so we have to now remove from the beginning. Okay, so we have our start variable, and we are going to decrement whatever's currently in our start variable, which is this E. So we go ahead and decrement E, and we move start over 1. And now we check, do we still have greater than 2? We do. So what do we do then? We have to, again, remove this C here. We just delete it, because there's only 1 there, so we delete it out of there, and we go ahead and increment our start. Okay? And so now we are back to 2. We have 2 variables, and then we're going to subtract 3 minus 2, which is 1, plus 1, which is 2. The length of our string here is 2. Is this greater than the max? No, it's not. So we don't do anything. We just keep max where it's at 3. Okay? Then we go ahead and increment the end here again. And again, we have A now, which is equal to 1. And this again is a problem, because now we have our size here is greater than K. And we have to go ahead and remove this E. We'll just delete it and then increment that start. And now we have BA. And we can also check, is the start and the end of 4 minus 3 plus 1, which is 2, is that bigger than the max here? No, it's not. And so then after we have moved through this entire string, we can just go ahead and return our max variable. That's going to be our answer right over there. Okay. And so what's our time and space complexity on this? Well, let's think about it. We have to go through every time we increment the end. We could technically have to pull up the start, right? So at most, we would go through these elements more than once. Okay, so our time at worst case would actually be O of n squared. All right. And what about our space? Well, we're not going to be creating new space with the max, but we will be creating space with this so far, right? And worst case, we would have a linear amount of elements in that space. And so here, we can also set this to O of n for space. Okay, and so we do get better performance here. We get better performance on space and better performance on time compared to the brute force using this sliding window approach. Okay, so let's go ahead and code this up. And again, this is a very common pattern. Highly suggest to be familiar with this. There are a lot of questions that are frequently asked that employ this sliding window pattern. Okay, so here, what is the first thing we're going to do? We want to set up our variables, right? We need a so far, set it to a map. We need a max that we want to set to 0, and we want to set our window start. So we can do let window start equals 0. Let our, we can use const here, const so far, and we can set that to new map. We want to set our max, let max, and we can set the initial value to 0. Okay, so now what do we want to do? We want to go ahead and iterate over this, so we're going to set our iterable to window end. We'll set that to 0. And then we can do, as long as window end is less than the length of the string, and then we increment window end. Okay, and so now what do we want to do? Well, first we want to update our so far. That's what we want to do every iteration. We got to update our so far. So let's pull out our right character, and that's going to be whatever is that string of window end. Okay, because remember, this end variable here is going to be our rightmost character at any point in our iteration, so we're just going to go ahead and pull that out. And then we want to update our map. So we can do if our map does not contain the right character, then we want to set it to 1. If it does contain the right character, then we want to take whatever that value is in the map and increment it by 1. So here we can say if so far dot get right character, then what do we want to do? We want to do so far dot set right character to 1. Else, what do we want to do? Okay, if it's not in there, then we want to go ahead and do so far dot set right character. That means if it is in there, to whatever the current value of that so far is. So we go and get that so far dot get our current value at right character, and then we add 1. Yes. Okay. And so now, what do we want to do? I believe we need one more parentheses here. No, that's good. Okay, so now what we want to do is we want to check the size. Right? We want to say while so far dot size is greater than k. Okay, so if we're outside, if the size is greater than k, so the size is going to be length of how many keys we have in our so far. If that is greater than k, then that means we have to decrement the window start and then move it to the right one. So let's go ahead and get our right character, our left character, and we want to do s of window start. That's going to be our leftmost character, because remember it starts at 0, and we're not going to increment any of it until we are outside of the range in our so far here. And so what we want to do is go ahead and pull that e and decrement it out of our so far here. Pull out that e and decrement that so far. So here we have our left character. What we're going to do now is we're going to say if the left character is in, if there are more than one left characters, then we just want to decrement it. If there's only one left character, then we want to delete it, right? So let's go ahead and do that logic. We can say if so far dot get left character is greater than 1, what do we want to do? We want to just decrement it. So we can do so far dot set left character so far dot get left character -1. Else, what do we want to do? We want to delete it. So far dot delete left character. And then what's the last thing we want to do? We want to increment our window. Window start ++. And then here, what we want to do is we want to update our max. So max is going to equal math.max, whatever is currently in our max, which is 0. And then we just want to do a window end minus window start +1. Why +1? Because we're dealing with length. Okay, so when we are dealing with window end and window start, we're dealing with index. But when we are dealing with max, what we're returning is dealing with length. Same thing with k. K is dealing with length. Okay, and then we just go ahead and return our max. Let's go ahead and run that. And yeah, and we have success. So that is Leetcode number 340, longest substring with at most k distinct characters. Very frequently asked question. Highly recommend being familiar with this pattern, and highly recommend being familiar with the sliding window pattern. It's just going to help you solve a lot of problems that deal with any sort of substrings or contiguous substrings or contiguous arrays. It just makes life a lot easier. So hope you enjoyed it, and I will see you on the next one.